Welcome. Today we're looking at exponential functions. We're just going to be talking about the exponential basic equation. Um, I should probably say and table here. So the reason we study exponentials is because they have applications in business, savings, biology, and chemistry, just to name a few of the areas that you might see exponential functions. So if we're looking at the exponential growth model, it's y equals a b to the x power. One thing to note is that the exponent only applies to the b, so when we're calculating, we make sure that we only raise the b to that exponent. The a is just multiplied with the b to the x part. A represents the initial amount, and then the b is the multiplier, and multiplier might not quite make sense to you right now, but then we'll talk about why it's called the multiplier and how it's applied. All right, so the first example asks us write an equation from the table. So whenever we have a table, we're used to checking out, all right, how is the x increasing or decreasing, and then how is the y increasing or decreasing, right? So that's the first thing we're going to do here. So notice on the left hand side, we're just adding 1 each time. -1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. Now on the right hand side, in the y column, in Algebra 1, we were used to seeing things go up by the same amount each time. But in this case, we're not adding to get from 3 to 9 and then from 9 to 27 and from 27 to 81. What we're doing is multiplying. So one of the characteristics of an exponential equation is that we're multiplying each time to get the new y value. So in this case, we're multiplying by 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So that's the first thing we want to do when we're given a table and asked to write an equation. We're going to go ahead and find out how much it's multiplied each time to get the new number in the y column. So now let's go ahead and write the equation. So let's rewrite this. Y equals a b to the x. Again, the a is the initial value. Now be very careful, because the initial value, another way to look at the initial value is the f of 0. Meaning, at 0 for my x, what is my value for y? It's easy to forget and think, oh, let's just start at the very beginning. That must be the initial value. But no, we're looking for the f of 0, meaning when x is 0, what is y? So in this case, we see that our y is 9. So that would be our initial value. So let's go ahead and write it. Y equals, our a is 9. Now b, we said, was the multiplier, right? So in this case, we're multiplying by 3 each time. So our multiplier is, not 1/3. Our multiplier is 3 because we're multiplying by 3 each time. And then we have our x. This is our equation. So we end up with y equals 9 times 3 to the x power. 9 again is the initial value. Initial. 3 is the multiplier. Okay, the second type of problem you're going to come across is fill in the table. So this is kind of like the reverse of what we just did. They're giving us the equation g of x equals 1/7 to the x power. Let's go ahead and fill this stuff out. Notice that we have this -2 here, right? So the problem with that is we're going to have g of -2 equals 1/7 to the -2nd power. Now, that's kind of hard to envision. So let's go on another sheet here. And let's look at a pattern. Now this doesn't apply directly to this problem, but the concept does. So let's just make a table here. Let's just say we're doing 2 to the x power. Let's say we have, this is our x and this is our y, and negative 2. Actually, let's start at positive. So let's say we have 2, 1, 0, negative 1, and 2. So let's fill in the first one. That's easy, right? 2 to the second power is the same thing as 2 times 2, right? The power tells us we're multiplying it by itself 2 times. So that's just going to give us 4. 2 to the first power is going to give us just 2. Now, if we have anything to the 0 power, now this is weird, but anything to the 0 power is going to be equal to 1. So remember that the multiplier, each time we go up one row, we times 2, right? So then 1 times 2 is going to give us 2. Anytime we have a negative power, the negative means to reciprocate. So if you notice the pattern going on here, is that if we're going up the row, we're multiplying by 2 each time. Over here, we're multiplying by 2. If we're going down, then the other way to look at it is that we're dividing by 2 each time. Also notice that if the exponent is 2, then the y is 4. If the exponent is negative 2, it's the same number, it's just the reciprocal of 4, which is 1/4. Same with 1. 1 is 2. Negative 1 is the reciprocal of 2. So one thing to note here, and if you don't want to do the table and think of it that way, I like to think of it that way because it helps me conceptualize everything that's going on. But the main thing to note here is that anything to the 0 power is 1. The second thing that we need to note is that the negative exponent, all that means to do is reciprocal. All right, so let's go back here. Let's take a look. So again, negative 2. All right, let's raise it to the second power. 1 to the second power is 1. 7 to the second power is going to be 49, and then we're going to reciprocate, so it's going to be 49 over 1, right? The negative, again, means to reciprocate. Now, we could write it as 49 over 1, but let's just make it a little simpler and write it as 49, because 49 divided by 1 is 49. Okay, so let's do the next one, g of negative 1. So we have 1/7 to the negative 1 power. Okay, the negative means reciprocate, so we're going to flip it over. And then 1 to the first power is 1. 7 to the first power is 7. 7 over 1 equals 7. Let's change colors here. Oh, this is 0 power, so g of 0. 1/7 to the 0 power. We just said from the other sheet that anything to the 0 power is 1. So the g of 0 is 1. Now the rest are pretty easy. So g of 1 is going to be 1/7 to the first power. There's no negative sign there. We don't have to reciprocate. Anything to the first power is itself. And then the last one, g of 2 equals 1/7 to the second power. So 1 to the second power is 1. 7 to the second power is 49. Alright, so again, just remember anything to the 0 power is 1. Whenever we have a negative exponent, all that means to do is to reciprocate. We're going to flip the fraction. Or if we have a whole number, put 1 over that number and then do your exponent. Alright. I know the negative exponent thing is a little bit weird, especially since you guys haven't really talked about it much. I hope that this thing right here helps some of us that like to conceptualize what it means and how it works. But it's one of those things that you're gonna have to be able to do fluently if you guys are going to go to pre-calculus and AP calculus eventually. It's something that shows up and it's just assumed that you guys already know how to do it. So the better we can get at it now, and it's gonna pop up from time to time in Algebra 2, but the better we get at it right now, the better for you guys in the long run. Alright, so again, please make sure you take your notes, write down any questions that you have about them, and then we can talk about them next class. Alright, good job.